Hi everybody, today we're going to talk about scientific notation. So I've compiled a list of questions and things you should be able to do after you watch this video. After this video, you should be able to tell me why we use scientific notation to express numbers. You should be able to identify numbers as either scientific notation or standard notation. You should be able to convert a number from scientific notation to standard notation and vice versa, from standard notation to scientific notation. Scientific notation can be used to express any number as a number between 1 and 10, which is called the coefficient, multiplied by 10 raised to a power, which is your exponent. So if we have a really large number, for example, okay, we'll add a lot of zeros and we'll give it units because we did talk about units. So we'll say we're measuring a distance and we're talking about meters. So we have a really large number. We want to express this number in scientific notation. What we're going to do is we're going to express the number as a coefficient, a number between 1 and 10. In order to do that, we are going to place the decimal wherever we can to create a number between 1 and 10. This number right now is not between 1 and 10, but if we put the decimal right here between the 4 and the 7, we create a number that is 4.73. All of these zeros can be left off because they're not significant zeros. Remember we talked about sig figs? So we've created a number between 1 and 10, which is 4.73, and now we have to figure out what our power is. So our scientific notation number has to be multiplied by 10, so we're going to go times 10. So we have a coefficient times 10. Now we're going to determine our power. The power is based on how many places you moved the decimal from where it was in the original number, which it would have been back here, to where you put it to make your coefficient. So we're going to count 13 places from where the decimal was in the original or the standard notation number to where we put it to make our number between 1 and 10. So we have 4.73 times 10 to the 13th. And remember, we talked about our shortcuts. Your standard notation number determines your exponent, or your exponent determines your standard notation number. Okay? So if you have a standard notation number that is greater than 1, your exponent is going to be positive. Because this number was greater than 1, our exponent is going to be positive. Let's do an example of a number less than 1 where our exponent is going to be negative. Let's say we're dealing with a really, really small number. And we'll give it units. We'll say that this one is grams. So we're measuring mass here. Remember, because grams is the base unit, SI base unit for mass. So we're dealing with a really, really small number, so we know we're going to have a negative exponent. But first, let's do our scientific notation. We need to make our coefficient. So how can we turn this number into a number between 1 and 10? We can turn this into a number between 1 and 10 by adding our decimal between the 7 and the 2. That's going to make our number 7.2. That's definitely a number between 1 and 10. Now we have to multiply by 10 and figure out our exponent. We figure out our exponent by counting the number of places between where the decimal started in the original standard notation number and where we put it to create our coefficient between 1 and 10. So this time I counted 8 places. And because our number was less than 1 to start out with, we have a negative 8 exponent. Okay, let's do some practice examples. So here, what I want you to do is we're just going to practice recognizing numbers that are scientific notation versus numbers that are standard notation. So I want you to write these down in your notes, and then you're going to highlight the numbers that are scientific notation and circle the numbers that are in standard notation. Pause the video and practice. We're going to go over the answers in just a second. All right, our first number is 1,392,000. That number doesn't have, it's greater than 10. There is no times 10 and there's no exponent. So this number must be standard notation. So we're going to circle it. The next number is a decimal point, 0.000000028. That's not a number between 1 and 10. There's no times 10 and there's no exponent. So this again must be a standard notation number. So we're going to circle that one as well. Next, we have 100 times 10 to the 5th. This one does have a multiplied by 10 and it is raised to a power, but because there's 100 is not a number between 1 and 10, this is not scientific notation. This is actually an example of neither scientific or standard notation. So you wouldn't actually write a number in this manner. Next, we have 3,549. That's greater than 10. There's no multiplied by 10 and there's no exponent. So this would be a standard notation number. Next, again, no times 10 to an exponent, so that is also standard notation. And 193.546 is also standard notation. Our next example, 1.3456 times 10 to the 6th. We have 1.3456. That is definitely a number between 1 and 10, so that's an okay coefficient. We have multiplied by 10 and we're raised to the power of 6. That's an exponent. That means that this number is scientific notation. So we're going to go ahead and highlight it. Next, we have 35 times 10 to the negative 4th. While you might be tempted to call this scientific notation because of the 10 to the negative 4th, 35 is not a number between 1 and 10. So this is just like this one here where it's not actually a real scientific notation number. 6.7894 times 10 to the negative 8. We have times 10 to the negative 8. That's times 10 raised to a power. 6.7894. That is a number between 1 and 10. So that counts as proper scientific notation. You can go ahead and highlight it. 1.00, because there's no times 10 raised to a power, this is going to be a standard number. 12 is a standard number. And last, 1.2 times 10 to the 1st is a scientific notation number. Okay, so we had a couple of trick questions in there. Hopefully you guys are getting the hang of scientific notation versus standard notation. Next, I want to actually practice converting from standard notation to scientific notation. So we're going to do these few practice problems, pause the video, and then we're going to go over the answers. First, we need to make, so this first one is a standard notation number. So we need to turn it into from 1,392,000 into a number between 1 and 10. We can do that by placing a decimal right here between the 1 and the 3. That turns this number into 1.392, and we can leave those trailing zeros off because they're not significant digits. And then we have to figure out our power. We're going to count from where the decimal started at the end of the number to where we put the decimal to make our coefficient, and we have 6 spaces. 1,392,000 is a big number. Remember our shortcut. If our standard number is greater than 1, our exponent is positive. If our standard number is less than 1, our exponent is negative. So this is a number greater than 1, so we are going to have a positive 6. Okay, let's practice on the next one. We need to make a number between 1 and 10. We have 0.00000028. To make this a number between 1 and 10, we're going to put the decimal right here. Our number between 1 and 10 becomes 2.8. We can leave all those zeros off because they are not significant zeros. Those are leading zeros. Times 10, and we're going to determine our power by counting the number of places between where the decimal started and where we put it to make our number between 1 and 10. So 2.8 times 10 to the 8th. But wait, our standard number was less than 1, so this has to be -8. 12 is just a little bit higher than 10, so we have to turn this into scientific notation. We're going to turn this into 1.2. Now it's between 1 and 10, and we only had to move the decimal place one spot to get it to scientific notation. So this is going to be 1.2 times 10 to the 1st. Okay, I'm going to skip on ahead. The next slide, I'll show you all of the answers. But I'm going to go over the next 3, converting from scientific notation to standard notation. So we're going to go through these examples right here. So we have 1.3456 times 10 to the 6th. We already have our exponent, but our exponent is positive, which means that our number is going to end up being greater than 1, which means we're going to move the decimal point in this direction to make a number bigger than 1. So we're going to write out our number, 1, 3, 4, 5, 6. Let's see, we move the decimal place and make it bigger. This would make it 13, 134, 1,345. See how we're making the number bigger by moving the decimal place to the right? So we're going to move it 6 places. 1, 2, 3, 4, 5, 6. That means this number had 2 hidden zeros or 2 trailing zeros that scientific notation got rid of. So our actual number, 1,345,600. We'll do this next one. I'll do it over here just so I have space. So we have 3.5 times 10 to the -4th. We have a negative exponent, which means we need to move the decimal to make a smaller number. So we're going to move the decimal this direction, 1, 2, 3, 4 places. And that means this number also had some hidden zeros that scientific notation got rid of. So this number is going to become 0.3 hidden zeros, 3, 5. This number here also has a negative exponent, so we have to move the decimal this direction to make a small number or a number less than 0. We're going to move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. That means we had 7 hidden zeros or 7 leading zeros. So 1, 2, 3, 4, 5, 6, 7. 6 is our 8th place, and then these numbers have to stay because remember, all non-zero numbers are significant. And then our last number, 5.0 times 10 to the 2nd. We have a positive exponent, so we're going to make our number bigger. We're going to move it 2 places this direction. This is actually 500 in standard notation. Okay, so here are the answers to the previous slide. If you have questions, we can go over your questions in class. Let's do a quick check-in. Hopefully you know now why we should use scientific notation. We can use them to express really, really big numbers and really, really small numbers, and they get rid of those insignificant zeros. You should be able to identify numbers as either scientific notation or standard notation. You should be able to convert from scientific to standard and convert from standard to scientific.